Hi everyone! In the last video, we derived our logic equations for a simple computer system that could say hi. If you haven't watched that, click on the link in the video description to watch that video first. In this video, we will see how can we draw our circuit diagram from these logic equations and how to actually build the circuit. Okay, the first thing we need is to draw our flip-flops. We have two flip-flops here, D1 and D2. So we go ahead and put our flip-flops in. Okay, this is two of the two flip-flops. It's called FDR. This FDR it doesn't stand for the famous American president. This FDR stands for F is because it's a flip-flop, stands for flip-flop. D stands for because it's a flip-flop of type D, and R represents a flip-flop that has got reset. So what is actually this reset? In the logic equations here, you can see the reset. There's no mention of reset. So, but we need this reset input because for reliability purposes. So the thing is, these logic equations work properly, assuming that when you turn on your system, inside of both of these flip-flops are 0, so the system is at state 0 0. But sometimes maybe there is, when you turn on your system, it can be a 1 in 1 or 2 of them, this flip-flop. So that if there is a 1 or 2 ones here in either of them or both of them, that may cause problems. So we don't want that. So we want a system that is reliable, it works every time. So we put this reset here. So what it does is actually, as soon as we turn on the system, it sends a signal to the flip-flops and force them to be 0, and this way it initializes them actually. So this is very important that we got this reset here. So now let's move on to the first logic equation. The first one is D1 plus equals D2. So what is actually D1 plus and D2? What is actually, so you see here, this flip-flops got D, C, and Q and R. So this R is for reset. This C, if you can see this, if I zoom in on this flip-flop, you see here that it's got Q, R, C, and D. So this R I explained is for reset. This C is for clock input, and this Q is the output of the flip-flop, and this D input is input of. But let's first name these flip-flops first. I name one of them D1, okay, and name the other one D2, okay. So if you zoom in here, so you see this now this one is actually D1 plus. So let me put a right in front of it as well so you can understand. So it's D1 plus. So this input is actually D1 plus, and this output here, this is D1. Same as here. This output here is actually D2, and this input here is D2 plus. So if we move, so as you can see here, this is the D1 plus and D2 plus are on the left side of the flip-flop, so they're like the input side, and D1 and D2 are on the right side or output side of the flip-flops. Because what is at the left side is actually the next state. This and the outputs represent the current state, and the input of the flip-flops represent the next state of the flip-flop. So what is the first equation says? It says d1 plus equals d2. So that means we have to connect d2 to d1 plus, and let's do that. So okay, I put a wire from d2 to d1 plus, and yeah, that's it. I just put it a little bit nicer to not be out of the. So now d1 plus is complete. So I just connected d2 to d1 plus, same as this equation says. So we're moving on to the next equation. The next equation says d2 plus equals b equals c equals g equals not d1 and not d2. So we have to make this signal. So for d2 plus first, we need two inverters or two NOT gates. And go to logic. Okay, this is two NOT gate or inverter, whatever you want to call. And then so I put this, connect that to here, and I connect this here to here. Okay. You see, now this d1 here comes out of all the way from this line and goes to this inverter or this NOT gate, and what comes out of the NOT gate is the opposite of it. So not d1. So this is not d1 and not d1, and this one here is not d2, which goes all the way here to d2. But what we want actually is these two ANDed together. So we find the AND gate, and 2. So here. Now let's actually put this AND a little bit back, further back. Okay. Now let's connect them together. Okay. So now these two are ANDed together, and now I can connect them to D2 plus. So here's how we do it. First, I put two NOT gates and connected D1 and D2 to these two. So this is D1, not D1, and this is not D2, which comes out of this D2, and then ANDed them together to create not D1 and not D2. So, and that's what the equation says must be D2 plus. But also B, C, and G, which are our outputs. So I just can get one output from here and put an output sign here, and I can do the same. So I connect them. So that's B, and that's C, and that's G. Okay, and now let's name them to be as B, as C, and that's output G. Okay, and this is done. And now, so you see these three outputs are exactly the same, and they come out of this this knot here. This knot both goes to the D2 plus and goes to this these three. So this is what the logic equations are. We're following these logic equations actually. So the last one says E equals F equals not D1. So we just have to get not D1. So not D1 here, if you follow D1, so D1 goes out of here and then goes to this inverter, and what actually on the other side of inverter is not D1. So D1 goes to the inverter and not D1 comes out, because inverter always reverses stuff. So I just put a wire here and create another output, and also create another output here, and also name them. So the first one should be E, the next one should be F. So see, these two outputs E and F are both connected into this NOT D1. So let's me okay. So now all of our circuit is we're almost done. So the only things that we haven't done is this clock and reset inputs. So we can do that as well. We first connect the clocks together, and let's put them a little bit this way, and create an input for them, and I explain later how can we actually build this clock inputs. So I just put clock. So this is my clock inputs, which goes to the both clock inputs of both of the flip-flops. And also I need my reset inputs, so I connect the two resets together. It doesn't like that. Okay. Okay, so this is my reset, and I write the name of it as well, reset. So this is my reset input. So this is the secret. This is what actually we're going to build. Oh, we got a reset input, which goes to the reset, both of these reset inputs of two flip-flops, and we got our clock input, that which goes to the clock input of the both flip-flops, and we have connected the connections from D1 and D2 to D1 plus and D2 plus, and we have our outputs here, over here. So we're done. This is now the only thing is left to actually physically build the circuit, which I will do in the next video. See you then. For now, thank you for watching.